So regarding your test, let me look at the questions. Yeah. So question 1A is clear, right? Do you have anything about question 1? Any problem? No question about question 1. Do you know how to solve this 2x plus 1 or 2x minus 1, sorry. 2x minus 1 plus x minus 3.
So case 1 is true.
So there are 3 cases, yes. So case 1 is when x greater than or equal to 3. So in this case, both expressions are positive. So this is positive, this is positive. So you can just take the absolute value. So that means in this case, so you get 2x minus 1 plus x minus 3 equal to 21. So that means 3x equal to 2x plus x is 3x, then equal to 24. So x equal to 8. But you have to check the condition. Is x greater than 3? Yes. So that is one answer. You keep it. Now case 2.
Yeah, I got 25 minus 25.
Oh, sorry, 25. 25, so it's 25 over 3. But it's still greater than 3, so we accept. So case 2. X between 3 and 1/2. And these numbers are basically the roots of each expression inside the absolute value. Yes.
In conclusion, do you write a number like x is equal to 25 over 3, or do you write the condition?
No, that is the answer. 25 over 3, that's the answer. But you have to check, does it satisfy the first condition? Yes or no? Here is yes. Now the second case is when x is between 1/2 and 3. In this case, 2x minus 1 is positive. So 2x minus 1 is positive, but x minus 3 is negative because x is less than 3. So when you take the absolute value, so you get 2x minus 1, but because x minus 3 is negative, so you get minus x minus 3. So 2x minus x is x, minus 1 minus minus 3. You take it to the other side. So minus 1 plus 3 is 2, 21. Minus 2 is 19. Is this between 1/2 and 3? No. So we don't accept it. So this is not an answer. So case 3 is when x is less than or equal to 1/2. In this case, both terms inside the absolute value are negative. So this is negative. The second term is negative. So when you take the absolute value, you have to multiply them by negative. So you get negative 2x minus 1, negative x minus 3 equal to 21. So on the left side, you have minus 2x minus x, you have minus 3x, and then you have plus 1 plus 3, which is 4. So when you take it to the right-hand side, you get 17. Because on the left side, you have 1 plus 3, which is 4. So you move it to the right side, you get minus 4 So minus 3x is equal to 17. That means x equal to minus 17 divided by 3. Is that less than 1/2? Yes, it is. So that's another answer. So we have in total 2 answers. One is x 25 over 3, another one minus 17 over 3.
On the test, would it be considered the wrong answer if we wrote like, it be x bigger than or equal to 3 and like, if we wrote the conditions other than x's?
What do you mean?
Because I didn't write 25 over 3 and x equals to negative 7 over 3. I wrote like the conditions that you check. That'd be wrong.
Yeah, that because we are looking for x, the value of x. The condition is a condition. It's not a solution. Okay. Okay. So now, so 1b, I guess. So 1b is the only trick is that. So let me just write it. So the question is x square root of x minus 2 plus x equal to 4. Yes, you can say that the square root of x minus 2 equal to 4 minus x, right? Now, once you have to take the square of the two sides, you do this squared is equal to this squared. So on the left side, you get x minus 2. On the right side, 4 minus x squared is x squared minus 8x plus 16, right? So that means you have this equation, x squared minus 9x plus 16 minus 2 minus 14 equal to 0. Not plus 14, sorry. Plus 18. Yeah, you take minus 2 to the right, you get plus 18. So, but this is what? This is just x minus 3 times x minus 6.
Isn't it minus 18 and then plus 9?
No, I take everything to the right side. So there are two answers. One is x equal to 3, x equal to 6. So here the only thing you have to be careful about is, because you have a square root of x minus 2, we know that the domain of a square root of x minus 2 is x greater than 2. So here there is a restriction in the first place. So you must have x greater than or equal to 2. Otherwise, the square root of x minus 2 doesn't have any meaning. So you have to check, are these two answers, do they satisfy the condition, the restriction? Yes, they do. So you can accept them. They satisfy this condition, right? So
would you sub the number in instead of saying a restriction that?
yeah. So for example, imagine that I obtain two answers. One is 3, one is 1. But x equal to 1 doesn't make sense because square root of 1 minus 2 doesn't make sense.
So we need to just write in restrictions.
Yes.
First, and just
Whenever you have a square root or ln, logarithm, there are restrictions on x. So when you solve equation.
What if we didn't state a restriction? Just sub the number in the equation to find which one is true.
That's fine.
Okay.
That's fine. That's okay. Okay. So that's question 1b. I assume 1c is easy, right? Or so for 1c, just let me tell you one point. For 1c, the equation is x cubed minus 6x squared plus 11x minus 6 equals 0. So for this question, I told you that x equal to 1 is a solution. Why it's the case?
Because x minus 1 is a
Because
factor, and then
coefficients-
x will be 1, and x is minus 1.
Yeah, but why we know that x minus 1 is a factor?
Because coefficients in the left side or just plus and 0.
Yeah, the sum of the coefficients on the left side. So you have 1 minus 6. What are the coefficients of this equation? You have 1x cubed minus 6 plus 11 minus 6. So if you add them, 1 minus 6 plus 11 minus 6, you get 0. So that means x equal to 1 is an answer. So that means you can divide this by x. So that means there is x minus 1 factor. So x cubed minus 6x squared plus 11x minus 6 equals to x minus 1 times something. So how you obtain the second factor? You just divide. You just divide just using long division. And then you get the second factor, and then, okay, is that clear? Liana, is it clear?
Wait, sir, can you say it again?
So I know that x minus 1, so x equal to 1 is a solution, right? Is that clear?
Oh, yeah.
Then that means x minus 1 is a factor of this polynomial.
Yep.
Because x equal to 1 is a solution, x minus 1 is a factor. So in order to get the second factor, you have to divide x cubed minus 6 squared plus 11x minus 6. You have to divide it by x minus 1.
Oh, okay.
So if you divide it, you get like x squared. So you just do the division.
Oh, okay.
And then minus 5x squared divided by x is minus 5x. So minus 5, so you get minus 5x squared. And then you have plus 5x minus 6. And then you subtract. You get 11 minus 5, so you get 6x minus 6, which is just 6. So the remainder is 0. So the other term, the other factor is just x squared minus 5x plus 6. So I put it here, x squared minus 5x plus 6. Again, you can factor it, 2. So let me just write it here. So that would be x minus 1 times x minus 2 times x minus 3. So then equal to 0, there are 3 answers, right? Either x equal to 1, or x equal to 2, or x equals 3. So for question 2 about the domain, so because you have a square root, for each case you have to solve. For example, let me look at 2b, sorry. So you have f of x equal to square root of 3x plus 1 over x squared minus 1. So you have to solve, because there is restriction for a square root, right? What is the restriction? The restriction would be 3x plus 1 divided by x squared minus 1 must be greater than or equal to 0. Right? So here on the top, you have 3x plus 1. What is the root of 3x plus 1? Is minus 1/2, 1 over 3, right? And then you have x squared minus 1 at the denominator. What are the roots of x squared minus 1? -1, and +1. So in total, you have 3 roots. So 3x plus 1 is 0 when x is -1/3. It's positive here, negative here. X squared minus 1 is 0 when x is plus or -1. It's negative between the roots, positive otherwise. But you have to look at 3x plus 1 over x squared minus 1. Remember, because x squared minus 1 is in the denominator, so when x equal to -1 or 1, so the fraction doesn't exist. So here does not exist. But when x equal to -1/3, the whole thing is 0. Now you just multiply the signs. Plus times plus is plus, or you can say divide. Division of the signs, it's the same as multiplication. Plus divided by minus is minus, minus divided by minus is plus, minus plus is minus. So you are looking for greater than or equal to 0. So it's either this region or this region. So that means you must have, and you exclude -1 and 1 from the domain. So that means x is either between -1 and -1/3 or x greater than 1. So that's the domain. In terms of the intervals, it's -1 to -1/3, union with 1 to infinity. Oh, yeah. Sorry, that's yeah. Good point. Thank you. It could be 1 -1/3. There is equality here. Thank you. So it can be equal to -1/3. So here you have a closed interval. Yes, it can be -1/3. Okay. And for the other ones, you do the same thing. Like, for example, if you have f of x equal to square root of x to the power 4 minus 16, x to the power 4 minus 16 is x squared minus 4 times x squared plus 4, right? But x squared plus 4 is always positive. This guy is always positive. It's always greater than 4, right? So it only depends on the sign of x squared minus 4. So you have x squared minus 4, and then x squared minus 4 times x squared plus 4. Or maybe I just write both of them.
Can't you simplify x squared minus 1 to?
Yeah. It's x plus 2 times x minus 2. That's right. So what are the roots of x squared minus 4? -2 and 2, right? These are the two roots of x squared minus 4. And it's 0 when x equal to 2 or -2. Between the two roots is negative, then positive. As I said, x squared plus 4 is always, no matter what x is, it's always positive. So that means that the whole thing is just positive, negative, positive. So what is the answer is, and it's here 0, 0, 0. And the answer is this region and this region. So that means is either x less than or equal to -2 or x greater than or equal to 2. So in terms of the interval notation, from negative infinity to negative 2 inclusive, union with 2 inclusive with 2 infinity. Okay? So for just maybe one, is there anything else from this question that you want me to discuss? Other questions?
If I just forgot to write a equal in the this x less than or equal to -2, you lose the mark.
You lose half of the mark. No, I'm kidding. Yeah. I removed some little marks.
Have you marked our test yet?
No, not.
Why? Are you going to tell us when you mark our test?
So, Yediar, do you have any question about other questions?
No, actually, no. I'm good.
You're good?
Yeah.
Okay.
Thank you.
Okay, no problem. So let me continue our discussion of exponential and logarithm.
So you didn't switch x and y in the first place, right?
I did. I switched x and y in the first place, and then I solved for y.
Oh.
Now, can you guys compute the inverse of, again, compute the inverse of f of x equal to e to the power 5x minus 1 And by the way, let me go back to the previous question. Once I find the inverse, I should, if someone asks you, what is the domain of the inverse function? So imagine I ask you, find the inverse and state the domain of the inverse function. So the domain, because there's restriction for ln, right? So the domain of inverse function is that here, x must be greater than 2. Because x minus 2 must be positive. So the domain of inverse function here, the domain of inverse is the numbers bigger than 2.
So it can't be 0 as well, right? X minus 2 can't be 0.
Can be 0. ln, whatever the restriction, positive. Yeah, strictly positive. Now, can you compute the inverse of this function? Also try this one, the inverse of this function, g of x equal to square root of e to the power 5x minus 1. You can also try this one, h of x equal to a square root of the whole thing. So for the first one, remember that you have y equal to f inverse of x if and only if x equal to f of y. So that means x equal to e to the power 5y minus 1 plus 3. So that means e to the power 5y minus 1 is equal to x minus 3. So 5y minus 1 is ln of x minus 3. And 5y is ln of x minus 3 plus 1. So y is 1 over 5 ln of x minus 3. Now here, what is the domain? The domain is x greater than 3. What is the inverse of the second function, g of x? Mhm.
Ln of x minus 3 squared plus 1.
Yes, that's right.
Can you show the process?
Yes, so for g of x, this is g. Let me copy just this. So again, for the inverse, y equal to g inverse means x equal to g of y. So x is, what is g of y? E to the power 5y minus 1 plus 3. So that means x, so let me just write square root of. So here you can do in two ways. The square root of e to the power 5y minus 1 is e to the power 5y minus 1 over 2. Because square root is to the power 1/2, right? Let me write it here. So you have e to the power 5y minus 1 to the power 1/2.
You can't square the other side and then,
I could do that.
oh,
Yes. Okay. So that means e to the power 5y minus 1. Let me write it better. you have 5y minus 1 over 2 equal to x minus 3. So that means 5y minus 1 over 2 is ln of x minus 3. So 5y minus 1 is 2 times ln of x minus 3. So that means 5y is 2 times ln of x minus 3 plus 1. So that means y equal to 2 over 5 ln of x minus 3 plus 1 over 5. And that is the G inverse, because y is the G inverse. Okay. Now let's compute the inverse of, so compute the inverse of f of x equal to sine hyperbolic of x, which is equal to e to the power x minus e to the power negative x over 2.
HS.
I didn't do hx. Do you want me to do? I will explain this later. It's similar. It's exactly similar pattern. Now we want to try to compute the inverse of this. Okay, so for the inverse, again, y equal to f inverse of x if and only if x equal to f of y. So x equal to f of y means x equal to e to the power y minus e to the power minus y over 2. So that means 2x equal to e to the power y minus e to the power minus y. Now here is a trick. You have to multiply this whole equation by e to the power y. Multiply this by e to the power y, the whole equation. So once you multiply this, you get 2x e to the power y equal to e to the power 2y minus 1. Because e to the power y times e to the power minus 1 is just 1. So the equation would be e to the power 2y minus 2x e to the power y minus 1 equal to 0. It's a exactly, it's a quadratic in terms of e to the power y. So this is a little bit complex problem. So you have to do it in several steps. Okay, so it's a quadratic in e to the power y. So let e to the power y be t, for example. So let e to the power y be t. Then e to the power 2y is equal to t squared. Do you agree? So that means here you have t squared minus 2x times t minus 1. Minus 2xt. Right? Now, what is the solution for this quadratics? So t is, there are two solutions. Either you have the quadratic formula, 2x plus minus square root of b squared minus 4ac. So 4x squared plus 4 divided by 2, right? But remember that t is e to the power y. So t is a positive number. No, it's a, 2a. The a coefficient of t squared is 1. So first of all, you can simplify this expression. Let me just, because you can divide this by 2. So if you simplify this, you get t equal to 2x divided by 2 is x. If you take 2 to the square root, 4x squared divided by 4 is just x squared and then plus 1. I just divide this the two terms by 2. Okay, now remember that t was e to the power y, right? That means t must be positive. So here, square root of x squared plus 1, square root of x squared plus 1 is always greater than x. Do you agree? So that means you cannot accept that. So that means x minus square root of x squared plus 1 could be this negative. Do you know why square root of x squared plus 1 is greater than x? No, you know, you see that, so exactly. So it's a square root of x squared is x, right? Square root of x squared is x. But once you add 1, it's something greater than x, right? So that means you cannot accept the negative sign because it would be negative. So t would be x plus square root of x squared plus 1. But what is t? T is e to the power y. So e to the power y is equal to that. That means y would be ln of x plus square root of x plus 1. Beautiful. That is the inverse. So the inverse of sine hyperbolic of x is ln of x plus square root of x squared plus 1. Okay. So these are all examples that I told you so far are inverse of some exponential functions. You can compute inverse of some logarithmic functions. So it's basically the opposite of this direction. So in the last examples, we go from exponential to logarithm. The opposite direction is going from logarithm to exponential. So okay. Is that clear?